Hello, welcome back. This is a follow-up to the video where I talked about oxidation states and I gave you 6 examples to try. In this video, we're going to go through those examples, work through them, and you can try them in the original video first, which you'll find here. And you can check your answers and your understanding as we go along. If we haven't met before, I'm Matthew Macario. I'm a tutor, mentor, and coach to chemistry students just like you. And I do this to help you get from point A to grade A. Grade A sounds like what you want, right? Let me know in the comments. In that previous video, the examples I asked you to try were to work out the oxidation states of phosphorus in PCl5 and in PCl3, and of sulfur in SO2, in H2S, in the sulfate ion SO42-, and in SF2. Let's go through those one by one. We'll start with phosphorus in PCl5. Let's think about some of the rules we talked about and some of the common oxidation states too. So rules we talked about in that previous video, rules that apply when you're calculating oxidation states, include that substances with no charge, so compounds, have oxidation states for the constituent atoms that add up to 0 overall. They add up to 0. Individual atoms in compounds won't normally have oxidation state 0, but when you add them all up, you'll have a total of 0. And that is no different in PCl5. We also mentioned that chlorine is one of those compounds that has almost always got the -1 oxidation state when in a compound when bonded with some other element. There is an exception of when chlorine is bonded to oxygen, but obviously that's not the case here. So chlorine has a -1 oxidation state. And that is for each of the atoms. So that is a total of -5 for the chlorine atoms. And because the oxidation state of PCl5 must be 0 overall, the total oxidation states are 0, that must mean that the oxidation state of phosphorus is 0 minus those -5 of the chlorine atoms. And that, of course, means that the oxidation state of phosphorus in PCl5 is +5. Let's consider our other example that had phosphorus in, and this is PCl3. And again, we're going to calculate the oxidation state of the phosphorus atom there. Again, this is a neutral compound, so the overall oxidation states equal 0 when all added up. In this case, we have 3 chlorine atoms, and of course we already talked about they all have a -1 oxidation state each. So the oxidation state of phosphorus is 0 minus those -3. So that means the oxidation state of phosphorus in this compound is +3. Different from what it was in the compound we previously talked about, PCl5. And don't be concerned about that. Phosphorus is one of the elements that we don't identify as having one very common oxidation state. It has a range of oxidation states. I also set in that previous video a challenge to calculate the oxidation state of sulfur in various compounds and ions. And again, we'll see that sulfur is an element that has a variety of oxidation states that show up in different compounds, different chemical environments. The first one we're going to look at is sulfur in SO2. That was the first one I asked you to calculate. SO2 is a neutral compound. So overall, the oxidation states of the sulfur and the oxygens all added together will equal 0. Oxygen is one of those elements that does have very common oxidation states, and it usually has the -2 oxidation state per atom. It occasionally does have other oxidation states, but in most compounds, including this one, the oxidation state is -2 for each atom. So that must mean the oxidation state of sulfur can be calculated by subtracting the -4, the -2 for each of the 2 oxygen atoms is -4, subtracting that from the 0, which is the total oxidation state of the whole molecule, the whole compound. So that, of course, means that sulfur in this compound has an oxidation state of +4. The next example I gave was sulfur in H2S, hydrogen sulfide. Once again, this is a neutral compound, not an ion, so the sum of the oxidation states of the hydrogens and the sulfur atom will be 0. Hydrogen has a very common oxidation state of +1, and that is the oxidation state it's in this compound. So the oxidation state of sulfur must be 0 minus the +2 of the two hydrogens. So that means the oxidation state of sulfur in H2S is -2. So we had a positive oxidation state for sulfur in SO2 and a negative oxidation state in H2S. Again, that is nothing to be concerned about. Some elements do have available to them both positive and negative oxidation state. The next example I asked you to look at was sulfur in sulfate ion SO42-. Now in this example, we're dealing with an ion. The total of the oxidation states of the sulfur and the oxygen atoms present must equal the overall charge, which is 2-. The oxygen has the usual -2 oxidation state per atom. So that means that the oxidation state of sulfur must be -2, the overall oxidation state of the ion, minus the -8 of those 4 oxygens. And that means the oxidation state of sulfur in this ion is +6. Finally, let's look at sulfur in the compound SF2. So we're back to the situation where this is a neutral compound. So the overall oxidation states of the sulfur and the fluorines all added together does equal 0 again. Fluorine, when it is bonded to some other element, will always have a -1 oxidation state. The only time fluorine doesn't have a -1 oxidation state is when it's in its elemental form, and then just the same as every other element that's in its elemental form, the oxidation state would be 0. But here it's bonded to another element, so it is -1 oxidation state. What does that mean about the oxidation state of sulfur? How do we calculate that? Well, the oxidation state is going to be 0 minus the -2 of the fluorine atoms that are present. So that means that the sulfur in SF2 has a +2 oxidation state. So we've seen in the 4 compounds and ions we've looked at, we've seen sulfur with a +2, +4, +6 and -2 oxidation state. Sulfur does have a wide range of oxidation states, and all are quite easily found within compounds. How did you do with these when you did them yourself? Did you understand it straight away from the first video? Did you understand it from this one? Are you still struggling? Let me know in the comments. If you're really struggling, you can work with me too, so please do get in touch. I'll put the contact details in the comments below. Of course, if you've listened this far, I'm sure you found this useful, so make sure you're subscribed. Like the video as well, that would be really appreciated, and do tell a classmate about it. The more you do these things, the more other chemistry students will be able to learn too. Okay, thank you so much for your attention to this today. I appreciate you staying here to the end. Look after yourself, and I'll see you in the next episode.